Okay, let us get going. So in the last lesson, we spoke about this thing called an exponential function. And I want to ask, just what do you remember? So maybe some students can either put their hands up and tell me one thing, or you can put it in the chat. What are things that you remember from the last lesson about exponential functions? What is hanging around your brain? Did you remember to click save as? Always important to click save as, or I suppose on Google you'll think saves automatically, but yeah. What can you remember from the last lesson? So I remember that some graphs seem to kind of go up and some graphs seem to go down like that. Can anybody tell me if they remember anything about how these are different? Yes, so Annie says there are increasing and decreasing exponential functions. And so the green one is what we call a decreasing exponential function, and the red one is an increasing exponential function. So the simplest exponential function that we can get often looks like that. Can anybody tell me about how we get a decreasing exponential function and how we get an increasing exponential function? Can you remember what causes it to be increasing or decreasing? Siabonga says they don't have an axis of symmetry. You're absolutely right. So we know there's no axis of symmetry for the exponential functions. There is something else that's kind of sounds similar. I remember that. The equation has an exponent. Yes, the equation has an x in the exponent. So that is a really important one. That's what makes it an exponential function. When they are decreasing, the a value is a fraction, or we could say a is greater than 0 and less than 1. We actually can't have a negative a. That's not possible. But we can have, say, for example, a could be a third, or a could be 3/5. That would give us a decreasing exponential function if we have a fraction as the a value. Whereas an increasing exponential function will have a number greater than 1 as the sort of the base. So a will have to be greater than 1, so maybe like a 2 or 3 or 5 or even a 2.5. So that would be an increasing exponential function. Is this the one that has an asymptote? It is the one that has an asymptote. Yes, well done, Kawana. So there's no axis of symmetry, but there is an asymptote. And in the most basic exponential function, the asymptote sits on the x-axis. That's why these graphs don't cut the x-axis. There's no x-intercept. But in the last lesson, we also started to speak about what happens if we start to shift a basic exponential graph, like we have 3 to the x, and then we say, oh, we want to do that. We started to speak about how we could draw something like this. Can anybody remember? So the point is there is an asymptote, and normally we look at this number to help us know where the asymptote is. So that's what we spoke about in the last lesson. Can you remember the steps that we used to draw our different types of exponential functions? We can always go back. This is the magic of so identify the shape. Yes. So in the last lesson here, let's go back. We can see it here. Here it is in front of us. So we identified the shape, and then we also found the y-intercept, we found the x-intercept, and then we also found the asymptote. Annie, you are on the ball. Yes. Okay, so those are the 4 steps that we're going to keep in mind. So the shape, the y-intercept, the x-intercept, and the asymptote. And then we would draw them. Okay, so here is your first work for today. If there are any new students, you might feel a bit confused. And so I encourage you to ask a question. But for the rest of my students, I want you to try and draw for me. You're going to have to do some working out first. I want you to try and draw these 2 exponential functions. And I encourage you to go through the 4-step process for both. And then I want you to try and draw them for me. And if you feel confused or a bit uncertain, I really want you to put your hand up. I will come and help you. But let's see how you can do looking back from the previous lesson. I think this one will be just let me know, Simone, if there are any questions. It seems like okay for now that there's not too many questions, but if there are, just shout.
Will do, Peter.
Cool.
There was
Yeah.
a question from Kutlwano. I have answered it already, but just in case you wanted to explain it for anyone else who's wondering the same thing. He's asking, is it a must for it to be a horizontal asymptote?
Yeah, it is. It is. I'm trying to think if there's a case where it wouldn't be horizontal. No, so you would have to have a much more complicated composite function before any asymptotes would have to. So no, not at this level. It will never be an issue. No. So in order to find the asymptote Annie, you just go and look at this number here. Because in a simple exponential function, right? In a simple one, the asymptote is just sitting on this line here. But now what happens is this -4 comes along and it takes this asymptote down to here. And how much does it move it down by? It moves it down by 4. So that's why I have my asymptote being -4 in that case. So I hope that helps. How do you find the x-intercept? Aha. Okay, so this is going a little bit back to the previous lesson. To find the x-intercept, I made y naught. So if you think about putting a naught here, and I get naught equals 2 to the x minus 4, and then I moved the -4 across, and I had 4 equals 2 to the power of x. And then I said, what number, 2 to the power of what gives me 4? And I got x is 2. Now, in the second one, there is a little, I think there might be a problem in terms of it might not be obvious. We might have to sketch the graph without the x-intercept and just know that there is one, if there is indeed one. But I'll show you that little trick we can use. We can use logs if we really need to, if that comes up. But for now, I'm going to try and draw my graph here. So I like to put my anchor down first. And then let me put my two dots to check if they make sense. So there's one dot, and there is my other dot. And what the two dots do is they help me think, is it facing the right way? Because remember, what was the shape? It was that. Oh, it is the right way. Thank goodness. So here is my exponential, and this is -3, and this was 2. The function was called h. Okay, so that is the first function. Now you still need to do the working out and all that for the second one. So I see Anita said, so I see you have identified the shape, but why is it different to the one on the first side? Because of the positive fraction. Yes. So what's causing the shape to be different is the fact that the base for the exponent is a fraction. And what happens when you multiply fractions repeatedly, they get smaller. So and it's not always obvious, like, but to give you an example, if you have a half, that's one thing. But if you go a half times a half, you get a quarter, and that's less. So this fraction being multiplied again and again is making it a decreasing function. So really it boils down to the base here. What about the y-intercept? That is going to be, which is 1 minus 2, which is -1. That seems okay to me. And what about the x-intercept? I'll give you a bit of time, but we might get stuck on this one, and that's fine because we can actually sort of draw this graph even if we don't have the intercept. We just need to know if it exists or not. And then, is there going to be an asymptote as well? That's another good question. So how did the shape change? So the reason the shape changed is because of the this thing. Can you see how a is less than 1 and greater than 0, whereas here the a value is greater than 2. Well, not greater than 2, it's greater than 1. It's 2. So it's what's causing the change in shape is that. Okay, let's try and find the x-intercept if there is one. So we make y equal to 0, and then we have 3/5 to the power of x minus 2. And honestly, you wouldn't be expected to work this out, but what you need to know is there is an x-intercept. So if I try to solve this equation, what I would normally do is I get to this point. And to be honest, in grade 11, you're not expected to know how to solve that equation. So what you can do is just go, there is an x-intercept. I just don't know what it is, but I can draw it in and not label it. I will come back and show you at the end how to get it, but you only really need to know that from grade 12 onwards. So what is the asymptote? The asymptote is going to be y minus 2. So how do I draw this graph? I put this in over here, and I get y is equal to -2, and I have one dot so far. It is over here. Now here is the thing. You don't know what the x-intercept is, but you know that it exists. And if you look at the shape of this graph, it's just going to look like that. And you know that the y-intercept is -1. And the x-intercept, you don't know what it is, so you can leave it blank for now, but there is one because you can see the equation could be solved. Now, if you are super curious and you really have to know what that x-intercept is, there's a piece of math that you do in matric called logarithms, and it will allow you to solve this equation. And all you would need to do is you would put the base in the bottom square. So basically in your calculator, you would write 3 over 5 here, and then over here you would put 2, and then you'd get x. If you put that in your calculator, you'll get the answer, but you're not expected to know this is the stage. I'm just doing it as a bonus. So you can tell me what you get in the chat. I'm guessing it has to be negative, because can you see if you look at the graph, it kind of has to end up being negative, otherwise it won't make sense. So Annie says she gets negative 0.74. Does anybody else get something like that? Okay, let me get my calculator again, because you might be in radians or something else, just in case to confirm. Oh, I see lots of people are getting, oh yeah. Okay, so Annie says also negative. So we're getting negative 1.36, but you would get that. And the equation's name is F. Okay, so we have done drawing an increasing exponential function, and we've done drawing a decreasing exponential function, and it was good. I can see a couple of you needed to understand the difference there. I want to move on to a slightly different type of question now. So take a screenshot if you need to of what's on the board. And then we're going to talk about what if they give us a drawing and we need to find the equation of the graph. Okay, so that's what we're moving to next. So here's an example of a question like that. So it says, the curve of an exponential function is given by f of x equals k to the x. Now, this isn't what I call a funky exponential function. It's a pretty simple one because it's just got a base and a power. So that's good news for us. It says that it cuts the y-axis at 0, 1, and it cuts and while B, the point B is the point 294, and there's the point B over there. Calculate the equation of the function f. Now, if we look at what they're asking us, they're really saying, what is the value of this thing inside here? Does anybody have an idea or a suggestion that they can make as to how we might be able to find this unknown base? Maybe someone could put their hand up, or they can. I'm wondering if you've seen anything along these lines that you can, or you can think what in other areas of functions that we've done, what technique could we use that we've used before? Amakalema. You have said put substitution. So I'm assuming you're going to say the point 294. And okay, well then we must be careful that, so this is written as y equals, let's make it k to the x. Let me leave it as k. So if I was subbing in, I would put the 9 over 4 here, and I would put the 2 over here. Because if you look here, there's an x and there's a y. Now, can anybody work out the value of k for me? So I think that's a good idea. I think that's a good idea in terms of, I subbed in a point, but I still need to know what this value is. And I'm feeling like I'm on the right track, but I need a bit of help from the student body. How do we find out what k is? Oh, I'd love to hear a student's voice. Who feels like they can hop on the line, tell me what to do here? It's so much quicker than trying to type it out. I know somebody knows the answer. You can do it. Ayanda has said square roots, question mark. Anybody agree with her? Him? Madudu has said square root. It does seem square roots are getting quite a bit of attention. Yes, I think square rooting would be a good idea. And the reason is it would undo the square. It's the opposite or the inverse operation of this. So you'd get k on the one side. And then what's the square root of 9 over 4? Yeah, it's going to be 3 over 2. Siyabonga will come to you on the next question. I see that hand, but I think we've just popped in. So your equation is going to be f of x is equal to 3 over 2 to the x. And that's going to be the equation of that exponential function. Okay, give me a thumbs up if you followed that process. Give me a thumbs down if you are unsure about how I did that. Okay, cool. So all we did, I think there's a couple of thumbs down. All I did was I took a point on the line, and where I took that point, and that point was 2 and 9 over 4. And I said, look, this is an x and this is a y. So the x went here and the y went there. And then what I did was I solved for k. Don't worry, we'll get another chance to practice this now. That was just getting going. All right, now we're just going to do question. Let's do 2.1 together first. So we're all going to do it says here, the sketch represents the graph given by f of x equals a to the x. Write down the coordinates of a. So I want everyone to put what they think is the coordinates of a in the chat. Annie, so you're referring to, can we use the points A in the previous question? Point A will be useful in certain ways, but it wouldn't have helped us in the last one because the information, you'll see now in a moment why the y-intercept is useful for certain things, but it would have been better to go with the point B because it almost doesn't give you the information. Anything to the power of a 0 is 1. And so the point A actually has an x value of 0. Like x is 0 there. Who would like to come online and explain how they think I get to the value for A? I can see that A is in line with the point x is 0, or is in line with the value x is 0. I know that my equation is y is equal to a to the x. So how am I going to figure out this point? I need some suggestions from the brains in the room. So Annie has suggested 0.1. I want to know how, if you agree with Annie, how would you get that value? Like, did you see it in a vision? Did you have an idea about where it came from? You know, what's the thinking that got you there? That's what I'm interested in. Because maybe it's right, maybe it's not. I don't know. Or I'm not going to tell you yet anyway. So hearties, yes. Madudu, I agree. If you want the value of A, all you do is you put the value of x, which is 0, in this equation. And what is anything to the power of 0? It's 1. And so the point A has to be the point 0.1. And that makes sense when you're thinking about how we were drawing our graphs in the last session. Okay, next question. And this one will be so good too. How can we tell that A is between 0 and 1? Pop your hand up if you can give me an explanation or type one out. But this might be quicker to just say. How can we tell that the A value must be between 0 and 1? What gives it away in terms of the graph? What piece of evidence that you've seen before, that kind of what clue? The A value is not a fraction. It's decreasing, Ayanda has said. Because it's on the Y line, Madudu says, decreasing graph. Yes. I think the fact that this graph looks like it's a roller coaster or a plane that's coming into land tells me something. And so basically, I can say that A is between 0 and 1 because it's a decreasing exponential function. If the graph looked like this, then I would expect the A value to be greater than 1. Yeah. All right, last one before the break. We're going to take a break. I want you to determine A if the point B is 3 and 1/27. So determine A if B is the point 3 and 1/27. So that is the point B there. And they're saying work out what the A value is. Over to you guys. And then someone's going to tell me about how they figured it out. So it's saying use the point B, but find out the value of A, which is the base in the exponential function. What do you think my first step should be? Somebody pop it in the chat. What's our first step? How do I get going with this? Yeah, you sub in. Exactly. Yeah. So I have this, and I have the point 3 and 1/27. So that's good. I know this is X. I know that's Y. And so I get 1/27 equals 3 to the power of X. And now I need to figure out what X, oh, sorry, I've done it wrong, haven't I? I need to go, that A is the mystery, and this is the 3. Yes. Let me just make it all the same color. So that's 1/27. So now we're a bit stuck. What do we do next? Now I know I need some brain power here. Who's going to help me? I need to figure out what A is. What undoes cubing something? So at the moment, I'm cubing it, and I'd love to, yeah, let's go to Siyabonga. Siyabonga, what do you think? What would undo a cube?
It's going to be a cube root, sir.
Perfect. Exactly. So you cube root this side, and you cube root this side. And what did you get, Siyabonga?
I got 1/3, sir.
Perfect. That's it. Awesome. Okay. So the final answer here is going to be y equals 1/3 to the power of x. And that makes sense to me because when I look at the graph, I can see it's going like downhill, or it's coming in for landing, which makes me think, I know what's going on here. All right, everyone, we've done a solid half an hour. I think it's time that we all stand up. So please turn your cameras on. I want to see the room full of people standing up and just realizing that they need to take a break from their maths. So let's do that. Let me make sure I've got all the cameras so I can see you. And Konke and Siyabonga, Annie, I see you. Omwaba, I see you. Look at all the people of the class. Okay, everyone, look at me wearing my warm jersey. But let's do some exercise. Okay, so let's start. Start by just shaking up your arms. Pretend they're like rubber. Just shake them out. Shake out this arm. Shake out both arms. Shake out your legs. Pretend like you're just, I don't know, doing whatever. And let's just twist our stomachs for a bit, just sort of move around. You should hear a few clicks. And let's roll the shoulders back. And let's roll the shoulders forward. I can feel my brain getting clever again. There we go. And let's do some arms, small circles, and big circles. And change direction with the big circles and small circles. Okay, so hopefully you're a little bit looser. Now let us do some heart rate. And today we are going to do skipping. And we're just going to do 20 skips. So get your virtual skipping rope. Make sure you've got some space. And let's go in 3, 2, 1. 3, 7, 11. Okay, let's do 10 more. 1, 7, 8, 9, 10. And then let us have a seat. I definitely feel like I got my heart rate up, although jumping jacks does feel like it's more hardcore from my experience. And while maybe some of you are grabbing some water, here is your Math 24 challenge question for today. Can you make 24 using the red or the numbers on the red card? And if you're like Math 24 champion of the world, you can always have a go at the blue one as well. So over to you guys. And I'll put my top back on. Oh, it's cold. What have we got? Can anyone get me 24 using the red card? It's always good to try and make the factors of 24. So the factors of 24 are 12 and 2, 8 and 3, 6 and 4. Can you make any of those two numbers with a combination? Do you guys need a hint? Or did someone got the answer? I was thinking going 8 minus 5 might be a good starting point for the red one. So if you've got 8 minus 5, can you get using the other numbers? So see, what we try and do is we try and make 24 using the 4 numbers on the card. So for today, I'll help. So if you go 8 minus 5, you've used 2 numbers and you've got the value 3. But if you go 7 plus 1, you get 8. Now you've used up all the numbers on the card, but if you now go 3 times 8, you've got 24. Aha, and Melekiah had got it at the same time as me. So 8 minus 5 equals 3, and then Neo also got 8 minus 5 is 3 times 7 plus 1, which is 8. Fantastic. And then Anita said 7 minus 5. Okay, so I think a couple of you maybe are, but you haven't seen Math 24 for a while, but just to remind you, what we do is we have to use all 4 numbers on a card. And the goal is to use normal operations and try and get to 24. Now, for today, I'm not going to do the blue one, but yeah, it's just a game we play from time to time to help us. Oh, it seems like my It's low. Okay. So let's go back to the, I was so close with the blue. Don't worry, Vasa, you can get it going in the next time. So what I want to do next is I just want to quickly ask you, let's see if you can do, before I go back to that, let's try and do this one. I need to plug something in. And so I want you to try and find, this is a different type of exponential, well, it's still an exponential function, but it's written slightly differently. And I want to give you a chance to see, can you figure out what the value of A and the value of B is using what's here? And I'm going to give you some time to struggle while I go and plug my, my graphics thing in. There we go. Okay, so this is a little bit harder. Does anybody have some ideas about where to start if I want to figure out the equation of this exponential? I mean, it's a bit weird. We've never seen one exactly like this, but the question says the function, and the function has a exponent in it. So it must mean that this is a different type of exponential function that we haven't dealt with yet. So let's see, what method could we use, or what process? I mean, I was thinking, couldn't we just take this first point and sub it in and see what happens? Like, why don't we start with that? Why don't you take this very first point, sub it in, and tell me in the chat or raise your hand and tell me what you think you figured out. Who feels like they have some insight or some... If you sub this in, what do you figure out? Yeah, Siyabonga, let's go to you. What have you figured out?
Y is equals to -1.
Okay, so you go -1 for Y. And then?
0.
Okay, now what does that help us figure out? What do you know about anything to the power of 0? Naomi's onto this. So I think that you just helped me figure out that A is -1. Because if you look at B to the power of 0 must be 1. So you're then left with Y equals -1, and then you've got B to the X. But now you have to figure out what B is. Right? So you have to figure out what B is. Now, I'm going to leave this to you guys. Rosario agrees there. How do I figure out the next step? Who thinks they can help me figure out what, I know what A is, but now I need to figure out what B is. Naomi said use the other point. Naomi, I think that's a fantastic suggestion, because we know that that's kind of the main way that we, that's the main way that we, figure variables out, really. So I'll wait a bit and see who has a answer for me on that one. What value are you getting for B? So I know that this is X and this is Y. So I could put a -2 there, -1 there. B I don't know, and that's -1. Who can help me figure out this one? What do I have to do? Can I move this? I think I could move this thing to the other side. Like, at the moment, this is being multiplied. So then if I bring it to the other side, I should get that. So I've got 2 equals b to the minus 1. But now this is still a bit sneaky, because I want to know what b is. I know what b to the minus 1 is, but I really want to know what b is. And there's a couple of different ways you can deal with this problem. I'd love to hear from someone who knows how to deal with this. How do we deal with negative powers if we want to make them positive powers? Does anybody know? Can you remember from earlier in the year when we did exponents? Okay, Mbali and Zanelia, what do you remember about negative exponents?
Say b to the power of -1 will change and be a fraction. It's gonna be 1 all over b.
Perfect, yes. And then how do I get b by itself? So you're right, that's the exponent law.
I will times b both sides.
You get 2b equals 1. And then what was your final answer?
1 all over 2.
Yep, that's it. Well done. So what does that mean about the final answer? You have now found that the equation of this graph was minus for a, or minus 1, or we can just write minus a half to the power of x. And look at you guys, you've just figured out the equation of quite a funky looking exponential function. Okay, so now the question is, you figured out an exponential function that looks different to any of the exponential functions that you've drawn so far. How did this exponential function come to be? And the reason it looks different is because of this negative sign here and what we call reflecting over the axes. So the negative in front caused the basic shape that used to be up here. Well, let me see if I can draw it. It used to look like this. So if you imagine that was a decreasing exponential function, and when you put the negative in front, when it became a negative y, it ended up going down to here. So it was like the original shape was up here, and then when we put that negative in front of it, it flipped it over the x-axis. Now this automatically happens, hey? Like when you have, like if I have the value 2 and I reflect it over the x-axis, it gets to -2 over here. So you all know about that point. It's just a reflection. But what I'm going to do for the last 5 minutes is I'm going to show you how we do this with simple functions. I'll come back to that question now. So say, for example, we have the graph of y equals 2 to the x. Now, we've been studying that for a while. It's not a very exciting one, but it's a nice one to just sort of learn from. If I then, and I also know from previous questions that it goes through 1. If I now say to you, I want you to draw the graph, if I change the sign in front of the y, so let me write this down. If you change the sign in front of the y, you reflect over the x-axis. If you change the sign in front of the x, you reflect over the y-axis. So let's just see how this works. So if I change the sign in front of the y, I would get a negative y there. But we very rarely leave the negative over here. So what I do is I multiply both sides by -1, and I end up getting that graph. And the question then becomes, what does that graph look like if I draw it? take a moment and try and think about where I'm going to draw this graph. I want you to try and do it by yourself, and then I am going to draw the graph in and show you what it looks like in reality. But I've given you a little cheat sheet here. If you change the sign in front of the y, you reflect over the x-axis. If you change the sign in front of the x, you reflect over the y-axis. What do you think? I've drawn the green graph already. What is this one over here going to look like? Give me a thumbs up if you've drawn your own copy, you've drawn your own version. You had a guess about where you think it is. Give me a thumbs down if you haven't drawn your own version yet. Okay. So if I've changed the sign in front of the y, I need to reflect over the x-axis. So if you reflect the 1 over the x-axis, you're going to get here, and you'll get -1. And the graph is just going to look like that. The asymptote, the +0, is still there. There's still an asymptote that's sitting between the two. It's just that the green one has been reflected over the x-axis. And so that's what the negative in front here does. It changes it by reflecting it over the x-axis. So let's try another one like this, so you can keep testing up your reflecting skills. Say I give you the equation y equals a quarter to the power of x. And I'm going to save you some working out because we know that graph of that, which we can rewrite as this. And when you've drawn it, give me a thumbs up in the chat, so I know that you had a chance to try and draw it. Okay, so if you're reflecting this graph over the x-axis, because you changed the sign in front of the y, the point 1, when it's reflected over the x-axis, will get to -1. But we need to look at the shape here, and the shape is going to look slightly different. It's going to look like that. And this is going to be -1 over here. So this is how we get the different exponential function shapes. And just to show you that the algebra is also telling us the truth. If I had taken this equation and I said, I want to find the y-intercept. In order to find the y-intercept, I would have taken x and made it 0. And then I would have said, well, that's going to be minus times 1, which is -1. And that's exactly what I was hoping for. So the algebra is telling the same story as the the graph. Here we have a little bit more time. So let us let's do this last one here. Let's see if we can squeeze this in. We might run out of time. So here's the graph of f of x equals 8 to the x is drawn below with the point q minus 3, 8. Find me A, find me P, and then find me G of x, which is the reflection of f of x So yeah, try and do that last one there. So we'll call them, for sake of time, we'll call them A, B, C, and D. And then we're done for today. Over to you guys. So the value of A is -3. I don't think it's not quite -3. We have to work out what this thing is over here. And if I go 8 is equal to that, I think what I want to do is I want to pull the trick that I pulled before, where I made the negative a positive, and then I got, being a little bit sneaky, but I've got, so now the question is, can you find me the cube root of 1/8? And that's going to give me the value for A. So think about it. You took, this was a little bit of a rush now, but that's Y and that's X. There's my X and there's my Y. And then the problem is I had a negative power. So to get a positive power, I brought it below the line. And then I had to move across. And then I moved the 8. So I get that. Now I need to take the cube root of both sides here. So cube root of this, and the cube root of that. Naomi has said that we get a half. Okay. Was there a hand from Siyabonga there? Okay. Here's a half. There we go. Okay, now, unfortunately, we have run out of time, so I'm going to give you the answer for P. The answer for P is just going to be 0, 1. So that's going to be the answer for that. The last thing for today, I just want to know if g of x is a reflection of f of x in the x-axis. Okay, so you've got f of x is equal to a half to the power of x. This question is saying, what is g of x if this is reflected across the x-axis? What is this answer going to be? And what we've seen so far is that if we reflect it over, we just go a minus, and then it's a half to the power of x. And that is it. All right, everyone, I've pushed it right to the end. I did quite a lot with you today, but I think we had a good lesson.